Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on August 14th, 2025, about 4 days ago. It introduces a new user interface agent called UI Venus that achieves a new state-of-the-art, hitting 95.3% accuracy on the ScreenSpot v2 benchmark with its 72 billion parameter model. The paper is titled UI Venus Technical Report, Building High-Performance UI Agents with RFT, and its approach to training is what really sets it apart. The authors achieve this using Reinforcement Finetuning, which trains models using rewards for correct actions, alongside very careful data cleaning and a novel self-evolving framework to improve navigation. Also, the authors shared their implementation on GitHub, and it's a very complete package. You'll find the model checkpoints for both the 7B and 72B versions, the full evaluation pipeline, and all the scripts you need to run inferences and reproduce their work. So you can really test it out. On Hugging Face, you'll find the 8 billion parameter ground and Navi models, complete with weights and code examples ready for you to download and try out. Alright, so this first figure really visualizes their state-of-the-art results across two key areas. On the left are the grounding benchmarks, which test how well the agent identifies specific user interface elements on a screen. You can see the UI Venus Ground 72B model is the top performer across all 4 of these benchmarks, including ScreenSpot v2. Then, on the right, we have the navigation results for the Android World benchmark. This measures the success rate for completing multi-step tasks. And here again, UI Venus Navi 72B achieves the highest score. So let's look at how these two specialized models actually work in practice. The top part of this diagram illustrates the UI Venus Ground model. For this grounding task, the model takes an instruction, like click the button to create a new project, and simply outputs the exact coordinates for that element on the screen. Then, the bottom part shows UI Venus Navi. This navigation task is more complex. It uses the current screen, the overall goal, and a history of its own thoughts and actions to decide the next step in a sequence. This table then details the data composition for that grounding task. They collected over 627,000 samples from 5 different open-source datasets, including sources like widget captioning and C-Click-Web. But after their intensive data cleaning process to remove noise and inconsistencies, they filtered that large initial pool down to a much more focused, high-quality set of about 107,000 samples. This smaller, cleaner dataset is what they actually used for training the UI Venus Ground model, which really highlights their focus on data quality over sheer quantity. Now for the navigation model, the authors introduce a really innovative process called self-evolving trajectory, history alignment, and enhancement. This diagram shows how it works between training epochs. The first component, trajectory history alignment, refines the model's reasoning. It generates multiple thought-action pairs, filters for ones where the action was correct, and then updates the historical context with these better thoughts. The second component, sparse action enhancement, focuses on rare but critical actions, like a long press, creating multiple training variants to ensure the model learns them effectively. Alright, let's dive into the grounding performance. This table lays out the results on the ScreenSpot v2 benchmark, which is a really comprehensive test across mobile, desktop, and web environments. If you look at the bottom rows here, the UI Venus models are consistently at the top. The 72B version, in particular, hits a 95.3% average score, which is a new state-of-the-art, surpassing other strong models like GTA-1. Even the smaller 7B model performs exceptionally well, outperforming many larger competitors. Okay, now let's shift to the navigation task. This table compares performance on the Android World benchmark, which tests an agent's ability to complete multi-step actions in a live environment. The UI Venus Navi 72B model achieves the top success rate at 65.9%. What's really impressive is that it does this using only screenshots. It doesn't rely on an accessibility tree, which is a structured data representation of UI elements. This screenshot-only approach is key for its strong generalization in real-world scenarios. So, wrapping up, the success of UI Venus really highlights 2 key ideas. First, that reinforcement fine-tuning on a smaller, meticulously cleaned dataset can achieve state-of-the-art results. And second, its screenshot-only approach is incredibly powerful for building agents that generalize well to real-world tasks. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.